Alright, so graphing systems of equations. Definition, system of equations. Two or more equations with one or more variables. Here's an example of a system of equations. Questions so far?
No, sir.
Yes? No? Alright, so we're going to solve this by graphing. What form do we want these in? What's the easiest form?
Slope intercept.
Slope intercept, unless right here we're in standard. We could find the x and y intercepts, but they don't come out evenly. So let's go ahead and put them in slope intercept form. So we're going to go here. Does everybody have those written down?
What?
Those two equations.
Yeah.
All right.
No.
I need somebody to read it back to me,
I'll do it.
because I'm going to go here.
Ready?
All right, read it back to me.
X plus 2y equals -7.
Okay.
And then 2x minus 3y equals 0.
All right, so the first one in slope intercept form would be 2y equals -x minus 7. So y would equal -1/2 of x minus 7/2. Second one would be -3y equals -2x. So y equals 2/3 x. And going back to the first one, what is your y-intercept?
What?
What is your y-intercept in the first one?
-7/2.
Which would be -3 1/2, correct?
Yeah.
So it'd be
Yes.
about right here. -7/2 is your y-intercept, which is -3.5. So put a point at -3.5.
What's the red writing?
That's your second line. That's what we'll get to next.
Oh,
Alright, so here, from here you go down 1, right 2, because that's my slope. Put a point, and draw a line. Alright, second one. What's your y-intercept?
There is not one.
So it's 0. What is your slope?
-2/3. There's no
Up 2 over 3. Draw your line. And if you're using graph paper, this is off a little bit, just because I'm not on paper. But we should intersect at -3, -2.
we have to graph it.
That's how we're solving these.
So the answer is -3, -2?
The solution is -3, -2. So what that means, if I were to plug -3, -2 in for x and y in both equations, it would give me a true statement. Okay? That is the only point that you could pick for to get a true statement from both of them. Yeah.
On the blue line, what's the other point? Like, how'd you get that?
Here?
Yeah.
That's from my slope. Your slope was down 1, right 2.
Oh, okay.
Okay?
Instead of saying 3 1/2, can't you just say 3 1/2?
Yeah.
Okay.
-3 1/2. We good? All right.
Wait. Okay.
All right. Write down these definitions. Parallel lines. Same slope, different y-intercept. Parallel lines will never intersect. So if they have the same, if two lines have the same slope and different y-intercept, they have to be parallel, and you would have no solution. Because remember, when you're solving these systems, you are looking for the point of intersection as your solution. So if they're not intersecting, then there would have to be no solution. Coinciding lines are same slope and same y-intercept, so they basically are the same line. They're two lines that lie directly on top of each other. And intersecting lines, to determine if two lines are intersecting lines, you look at their slopes. If the slopes are different, they have to be intersecting. We don't even have to worry about the y-intercept there. All right, so you should be able to classify. If I give you a system like they do down here, you should be able to classify that as either parallel, coinciding, or intersecting lines.
We would have to graph it first though to find that.
No.
No.
How
All
do
you have to
just looking at it?
Look
Oh,
at
oh,
these,
yeah, got it.
put them both in slope-intercept form, so I'm going to put the second one in slope-intercept form. Question?
No.
Okay, so the second one in slope-intercept form would be y equals 2x plus 1. What do we have here? Two lines with the same slope, different y-intercept. So that had to be parallel lines. So what's your solution?
No solution.
No solution.
What?
So if I asked you to classify it, you would say parallel lines. If I asked you to solve it, you would say no solution.
You have no solution if you had the same line, two of the same line.
If they're the same line,
They don't intersect, so
well, they're lying right on top of each other. So what's your solution? Many solutions.
Oh.
Okay? Infinitely many solutions if they're coinciding. If they're intersecting line, how many solutions do you get?
one.
One. And that one solution is your point of intersection.
The example was of a parallel line, right?